So let us now plot the pulse amplitude modulated wave. Plotting the pulse amplitude modulated waveform. Okay. So in SciLAB, basically what we do is we plot it by using the plot 2D3 instruction. Okay, and we take the samples at different frequencies. Let us define the time scale to be 1 to 100. That is defining the time instances. Okay, time instances where the sample has to be taken, and modulating frequency as 0.2. Then let us define message signal to be cosine signal, cos 2 into percentage pi into FM into T. And then plot it on a window which is 2 into 1. 2 into 1 means 2 rows, 1 column. Okay, 2 into 1 window, and it will take the first position. Then we can plot it, plot the message signal as T versus X. Plot the message signal T versus X. Then we can label it X label. X label could be, okay, so on the x-axis, because it is time, so let us write it time. And if you want to change its font size, let us take the font size to be, we can take it to be, let us take it to be 3, the font size to be 3. So this is your x-axis. What will be y-axis? Label. Y-axis we represent the amplitude, and let us take its font size to be, let us take it to be 3. And you can also, these are the attributes that you can choose in the instructions also, that axis attributes. And for example, I am defining the color. Let us define the color to be red. Attribute to be red. Okay, so this is for message signal. X label is time, Y label is font size, F, and font size to be 3, and color to be red. Okay, and then we can have X3 to be cos 2 into pi. Pi is represented as percentile pi into FM into T. Okay, before that we do it. Let us take the sampling frequency. Okay, X label ho gaya. You have to write down the title also. Also, let us take title to be the message signal. Title to the message signal. Then the plotted value, sampling frequency. We have to take the sampling frequency now. Let the sampling frequency be 0.02. Okay, 0.02. Okay, because the message signal is for 0.1, 0.4. Let us take it to be 0.4. The frequency, sampling frequency to be 0.4. Okay, and you can define the pulse amplitude modulated signal as cos 2 into percentile pi into FM into T divided by the sampling frequency of this. Okay. So these will be the instances where the sample is to be taken. Okay. Now again, we can use subplot to make its position at position 2 in the matrix 2 into 1. Then the plot 2D3. Plot 2D3 is the instruction which will be used to plot this sample, the pulse amplitude modulated wave. Plot 2D3 because it gives you the discrete values of the signal at the given sampling frequency. Then again X label, let us copy it from here. We don't have to find it. X label to be time and Y label to be amplitude, and it will be the pulse modulated signal. The second one. So I hope it will run. Let us take execute it. X label font size is not right. Okay. Font size. Okay. So this will be the pulse modulated. So pulse modulated signal. Okay, you can download it. If you change the sampling frequency, let us take it to 0.3, then it will be like this. 0.3 sampling तो ये इस तरीके से बनेगा, because the message signal is sinusoidal signal and it is taking the samples at the sampling frequency 0.3, or we can take it to be, let us say 25 इस तरीके से बनेगा. If you take the sampling frequency to be 0.25, okay. And you can choose it, download it. 0.05 ऐसे बनेगा. नेगेटिव में कुछ नहीं है. 0.1 को देखते हैं. Sampling, we are changing the sampling frequency. It is not So choice of sampling frequency is very, very crucial. Only then this true PAM will be generated. For example, in this you can see that the samples are taken at equidistant points and it is coming out to be almost the same as the pulsating. We cannot square wave. Okay, so the sampling is not good. So proper, let us take it to be 0.04. Yeah, this looks fine because it is giving you the idea of what the message signal is. So sampling, the choice of sampling is very, very important. For example, for earlier exercises we were taking the sampling rate to be inappropriate. That is why we were not getting the waveforms properly. Okay, but for this the sampling rate is good, and if I take it to be 0.3, then see what will happen. Yeah, it is also good. 0.5. So you can take output for different samplings. This is the message signal and this is the pulse amplitude modulated signal. Okay. You can download it and save it. So this is how you can plot pulse amplitude modulated signal on a SciLAB platform.